Hello students. So in the last class we have solved some numericals on root locus. So we'll continue the same topic. So problem statement of the numerical is sketch the root locus for an open loop transfer function g of s is equal to k into s plus 3 whole divided by s plus 2. Right. So here h of s is 1 here. So open loop transfer function what they have given is this one. Right. So from this given open loop transfer function, so you need to draw the root locus and comment on the stability, right? So solution goes in this way. So in the step number 1, so number of poles, the given open loop transfer function, CL. In the open loop transfer function, so we have the two s terms in the denominator, that is s and s plus 2. So therefore p equal to 2 means there are two poles, right? So the what about the location of those poles? So you need to equate these two terms to what? 0. So that is s equal to 0. 0 is the one location. So then s plus 2 equal to 0, so which results in s equal to minus 2. So therefore location of the poles are 0 and minus 2. Next, number of zeros in that. So need to compare here in the numerator part how many s terms are here. Only one s term is here. So that is s plus 3, right? So therefore z equal to 1. Its location is s equal to minus 3 by equating it to what? 0, right? So therefore, starting points of the root locus are 0, minus 2. So then end points of the root locus are minus 3 and infinite. So you can say that always root locus starts from open loop poles. So these are the poles location, right? So and ends with the open loop zeros. These are the open loop zeros. One zero is at minus 3, one more is not available here. So that is available at infinity, right? Next step is that locating RL and NRL region, right? So how to that? So draw the real axis and imaginary axis, draw the poles at 0 and minus 2, 1, 0 at minus 3, right? So now we need to find RL and NRL region. How to find those things? You stand on this branch, minus 2 to 0, see right hand side, how many poles are, zeros are there? So no zeros are here, only one pole at 0. So therefore 1 is an odd number. So this branch will become what? Root locus region. Then you stand on this branch, see right hand side how many poles and zeros are there. No zeros are there, but two poles are there at 0 and minus 2. So 2 is an even count. So this branch will become what? NRL region, right? So next you stand on this branch, see right hand side how many poles and zeros are there. Total 2 poles and 1 zeros are there. So total 3 is an odd count. So this branch will become what? RL region. This is how need to find RL and NRL region. Next, move on to the step 3. Number of asymptotes is given as p minus z is equal to 1. Means two poles are there, 1 zeros. So therefore, number of asymptote will be 1. Now, what is the angle of that? So we have the formula phi a, that is asymptotic angle is given as 2q plus 1, 180 degree divided by p minus z, where q is varying from 0, 1, 2 up to p minus z minus 1. So that is 2 minus minus 1 minus 1. That means 0. Q is 0. If I substitute Q equal to 0 here, so I'll get 180 degree divided by 1. So that is 180 degrees and what? Asymptotic angle, right? So what about the centroid? Since we have only one branch, actually no need of centroid also, but we'll calculate how exactly centroid will get. Sigma is equal to real parts of the poles, that is 0, minus 2, then minus of minus 3. So that results in what? 1. So at 1, so it is locating the centroid, means plus 1, right? So from that, asymptotic angle is 180 degree, means this real axis of negative part will be an asymptote, right? Okay, next, here also we have mentioned since one asymptote is there, no centroid is required. Centroid is not at all required. Since with an angle of 180 degree we have, centroid is not required. Next step is breakaway point. So how to find the breakaway point? So need to consider a characteristic equation. So what is a characteristic equation? So that is given as 1 plus g of s, h of s is equal to 0. So that is 1 plus k into s plus 3 whole divided by s plus 2 is equal to 0. If you take a LCM and simplify, we'll get s square plus 2s plus k s plus 3 is equal to 0. If I eliminate for k, so k will become what? Minus s square minus 2s whole divided by s plus 3. So we need to differentiate this with respect to s to get the breakaway points. So using u by v rules, so dk by ds is equal to denominator as it is s plus 3, differentiation of this numerator minus 2s minus 2 minus numerator as it is minus s square minus 2s into differentiation of s plus 3, that is 1 whole divided by s plus 3 whole square is equal to 0. Next, to equate it to 0, this denominator will goes to 0. Just to simplify this one, minus 2s square minus 6s minus 26 minus 6 plus s square plus 2s is equal to 0. So therefore s square plus 6s plus 6 is equal to 0. So if you're using calculator, if you simplify this one, so s will become what? Minus 1.2679, then minus 4.732. So here these both BAPs are valid. Both BAPs are breakaway points are valid because these two minus 1.2679 and minus 4.732 are lies in RL region. See, one BAP will rise in this region, RL region, one more in this RL region, right? So this is how both whatever the BAPs we got here, both are valid BAP. Next, step number 6, so which decides intersection with an imaginary axis. So how to find the root locus intersection with the imaginary axis? We have already that characteristic equation, that is s square plus s in bracket 2 plus k plus 3k is equal to 0. So need to write RH table here. Right, what is the coefficient of a s square here? It's a 1. Then constant, it's a 3k. Next coefficient of s, 2 plus k, then 0. So how to find this row? 2 plus k into 3k minus 1 into 0 whole divided by 2 plus k, that results in again 3k. So by the concept of RH criteria, so we can equate the first column values of RH table towards 0 to get the marginal value of k. So that is 2 plus k is equal to 0. K marginal will be minus 2. See, one more thing, k cannot be a negative value. So therefore, root locus lies on left hand side of S plane, means it will not go right hand side of S plane. The complete root locus will be present in the left hand side of S plane. That will see here how exactly it looks. Draw the first real axis and imaginary axis. Plot the poles here. One pole at 0, one more pole at minus 2, one 0 is at minus 3. This minus 2 to 0 is an RL region, right? So one more minus 3 to minus infinite will be again RL region. How exactly it works, we'll see. So we know always root locus starts from open loop poles where the k value is what? 0, right? So and it will trace and it will ends up, root locus will ends up at open loop zeros where the k value is infinite. Now, so the pole at 0 cannot go in this side. Why? Because this is NR region. This pole must come towards left hand side, right? So pole at minus 2 will not go in this way. So the pole at minus 2 must come in the right hand side. Why? Because this is R region. So this pole at minus 2 and pole at 0 will come towards each other. They will meet at this breakaway point, that is BAP1, that is minus 1.2679. So they will meet at this point, then they will split up in this way, so in other direction. So they will come and meet at one more breakaway point. Here also will come and meet at one more breakaway point. So one of the pole will come towards this 0 and they'll meet at this minus 3. So one more pole will come in this way and goes to what? Minus infinite to meet the zeros there. So through the BAP2, that is minus 4.732. So this is how the root locus takes place. So in detail of this root locus is as shown in diagram here. See, so minus 0 and minus 2 is on one pole, right? So at minus 3 we have a 0, right? So these two poles will come in this way, then they will meet at breakaway point, then they will split up in this way. In other direction, they will meet it here. One of the pole will come so in this direction and to meet the 0, right? So then one more pole will come in this way to meet the breakaway point, then it will go toward the negative of minus infinity. So to meet the 0 at that point, right? We'll stop it here.